So students, now we are going to study about refraction of light. Refraction of light. Right? Now this is going to be an interesting chapter and you are going to have fun. But students, let me recall you that we have already studied reflection of light. Isn't it? We have already studied reflection of light. So please pay attention between the difference between these two words, reflection and refraction. Okay, so look at the spelling. This is R-E-F-L-E-C-T-I-O-N and this is R-E-F-R-A-C-T-I-O-N. Okay, so these are two different things. Sometimes some of the students get confused between them. So let us start. So here we are going to talk about two different type of object, students. I'm sure you must be knowing about them already. One is called opaque object. One is called opaque object and another type of object which I'm going to talk about is called transparent object. Now students, tell me, what are these two different type of objects? What is an opaque object and what is a transparent object? So students, for example, take wood. Take wood. Take a iron block. Take a brick. So students, these are some of the substances. If you pass light through them, light cannot pass through these objects. Right? Light cannot pass through wood, iron or brick. But on the other hand, if you take glass, if you take water, if you take air, these are the things through which light can pass. Okay. So these are the things through which light cannot pass. These are the things through which light can pass. So these objects through which light can pass are called transparent objects, and these objects through which light cannot pass are called opaque objects. So students, we can write opaque objects are objects through which light cannot pass. Okay students, very simple thing. And transparent objects are objects through which light can pass. So students, here we are going to talk about two different type of objects. One is called opaque objects. Opaque objects, and another is called transparent objects. Transparent objects. Now what are opaque objects and what are transparent objects? Now students, think about wood, think about iron, think about bricks, and then also think about air, water, glass and such things. Do you see a difference between these things and these things? Yes friends, there is a difference. Light can travel through these objects. Light can travel through air, light can travel through water, light can travel through glass. So light can travel through transparent objects or transparent mediums. Okay students, so these are things through which light can travel, but these are things through which light cannot travel. So these are opaque objects or opaque mediums. So we can write light cannot travel through opaque objects. You understand my point, right? So it's a very simple thing. Some more examples of transparent objects can be kerosene. Kerosene is a oil which is used for cooking. No, kerosene is not an oil basically. Kerosene is something like petrol or diesel. It is something which is used for cooking in some of the houses. Then turpentine. It is also a kind of liquid through which light can actually travel. So these are transparent objects, and if you look in your room, you'll find so many things which are actually opaque, right? Now students, when light travels in these transparent objects, light travels in straight line. Light travels in straight line, isn't it? Light travels in straight line. Straight line. But there is a catch to it. There is a catch to it. This is not perfectly true, students. Suppose we have a transparent medium here and this is water. Suppose we have water here. So this is water, and above water we have air. Right, so in such a situation is very much possible. If you have a pond or swimming pool or a lake, you will have water below and air above it. Right, students? Now, say that this line actually separates water and air. So you can call this line as interface of air and water. Interface of air and water. Now see, if a ray of light comes from here, it is supposed to go like this. Right, students? It is supposed to go like this. It's supposed to go like this because we have seen that light travels in a straight line. But no, students. If a ray of light comes from air and goes into water, if a ray of light comes from air and then goes into water, it will not travel like this. It will not at all travel like this. See, till here, when it is traveling in air, then it is okay. It will travel in a straight line. But once it comes into the water, the ray will travel something like this. So you can see here, students, that the light ray was coming in air, it was traveling in a straight line, then it sort of gets bent. Can you see that it has actually bent a bit? So the ray has bent a bit, and once again when it travels in water, it will travel in a straight line. But when it crosses the interface, it will actually bend. Now this phenomena is called refraction of light. Students. When a ray of light goes from one medium to another medium, it actually bends. That is called refraction of light. This is true in a reverse sense also. Suppose a ray of light goes like this. So initially the ray of light was in water. Okay, so it was traveling in a straight line. Now when it will come into another medium, when it will start traveling in air, it will actually bend, students. It will bend like this. So this phenomena is called refraction of light. So we can write down, students, that bending of light while traveling from one medium to another. Is called refraction of light. Okay, students. So this phenomena of bending of light when it comes from one medium to another is called refraction of light. So this is the thing which we are going to study about in this chapter in great detail. So students, you can see this real life picture and you can clearly see refraction here. So see, this block which you are seeing is actually made up of glass, and in the surrounding you have air. Right here you have air, here also you have air. Now see, this is a ray of light which is coming. It is traveling in a straight line, but you can see when it enters glass slab, you can see the bending. Here, right? Then again it travels in a straight line inside the glass. But once again when it comes from glass to air, once again you can see the bending here. Right? So this bending of light on changing the medium is called refraction. So students, now it's time to see a very important term in this chapter, that is called refractive index. For that, we need to know that speed of light in vacuum is how much, students? We know that light can travel in vacuum. How do we know that, students? See, this is our sun, right, students? And this is earth where we live, right? So from sun, light comes to earth, isn't it? Sun emits light, and that light comes to earth, right? Every morning when we wake up, we see that sun rises and light from sun comes to earth. So what is there between sun and earth? There is nothing. There is nothing between sun and earth. So we can say that there is vacuum between sun and earth. When we say there is vacuum between sun and earth, what we mean is there is nothing between sun and earth. Okay, so you can see that light can travel through vacuum. You can clearly see that light can travel through vacuum. That's why it is able to reach earth. So light can travel through vacuum, and when it travels through vacuum, its speed is approximately 3 into 10 to the power 8 meter per second. Okay, the speed of light in vacuum is 3 into 10 to the power 8 meter per second. So when light travels through vacuum, its speed is this much. Okay, students. But students, suppose we have air here, right? In your room where you are currently sitting, there will be air. When light travels through this air, its speed is slightly different. So when light travels through air, its speed is slightly different. Now think of a glass slab. Now glass slab is nothing but a rectangular block of glass. When light travels through this, its speed is further different. Okay. Now think about oceans or rivers. Okay, so there is a lot of water in oceans. So suppose there is a lot of water here, it may be ocean or river, whatever. As we have already seen, students, that light can travel through water. So when light will travel through water, its speed will be different. So the point is, when light travels through water, when light travels through glass, when light travels through air, when light travels through vacuum, in all these cases, speed of light is different. So we can write, students, speed of light is different in different mediums. Right, students? The speed of light is different in different mediums. If it travels in vacuum, it travels with different speed. If it travels in air, it travels with different speeds. Glass, different speed. Water, different speed. Kerosene, different speed. Right? Another important point is the speed of light is maximum in vacuum. The speed of light is maximum in vacuum. We have seen that the speed of light in vacuum is 3 into 10 to the power 8 meter per second. Right? And that is the maximum possible speed of light. When light travels in any other medium, its speed is less. Next point is speed of light in air. Speed of light in air is also approximately 3 into 10 to the power 8 meter per second. So the actual thing is that the speed of light in air is slightly less than this value. This is the speed of light in vacuum. This is the maximum possible speed of light. When light travels in air, its speed is slightly less, but it is very slightly less. So generally we will say that the speed of light in air is 3 into 10 to the power 8 meter per second only. Okay. Then students, speed of light in glass. Speed of light in glass is generally 2 into 10 to the power 8 meter per second. So you can see this is less. When light travels in glass, its speed is 2 into 10 to the power 8 meter per second. Then the speed of light in water is 2.25 into 10 to the power 8 meter per second. Right? So you can see in different mediums, light travels with different speed. You don't need to remember all these data. The only thing which you need to remember here is that the speed of light in vacuum is this much and the speed of light in air is also this much. So students, now we'll see what is exactly this refractive index. So this term is actually represented by a symbol n, small n. Small n means refractive index. Now suppose we want to talk about refractive index of glass. Refractive index of glass. So refractive index is defined for transparent objects. So let's say we want to talk about refractive index of glass. So we'll denote it as NG. N stands for refractive index, G stands for glass, and the formula for finding this refractive index will be speed of light in vacuum. Speed of light in vacuum divided by speed of light in glass. This is the formula to find refractive index of glass. Now speed of light in vacuum is 3 into 10 to the power 8 meter per second, and speed of light in glass is, as we have seen, 2 into 10 to the power 8 meter per second. So clearly you can see it will come out to be 1.5. So refractive index of glass will be 1.5. Similarly, if you want to find, say, refractive index of water, so refractive index of water, it will be written as NW, okay, and it will be speed of light in vacuum divided by speed of light in water. Okay, so as we have already seen, speed of light in vacuum is 3 into 10 to the power 8 meter per second, and speed of light in water is 2.25 into 10 to the power 8. If you solve this, you will get 1.33. So that is refractive index of water. You understand? So basically we can write the formula that refractive index for a transparent medium, refractive index for a transparent medium denoted by this is equals to speed of light in vacuum divided by speed of light in that medium. This is the formula for finding refractive index of any transparent substance. One more small thing, students, this refractive index of glass or refractive index of water is also sometimes called as absolute refractive index. Absolute refractive index of glass, or absolute refractive index of water, or absolute refractive index of any substance. So you may or may not write this word absolute. You understand my point? If you say refractive index of glass or you say absolute refractive index of glass, both mean the same thing. Okay. Okay, tell me, what will the refractive index of air? What is the refractive index of air? Tell me. What is mu of air? Refractive index of air. So that will be speed of light in vacuum divided by speed of light in air, and both are almost same, so this will be 1. Now this is an important quantity, you must remember this, that refractive index of air is 1. Okay, students? So students, you can see this table here. So here you can see these are the transparent mediums, and in this column you will find refractive index, their refractive index. For example, for air, refractive index is 1.003, but approximately we will take it as 1. For ice, refractive index is 1.31. For water, refractive index is 1.33. For alcohol, kerosene, you can see the refractive index is fused quartz. This is some transparent object. You can see the refractive index for this. For turpentine oil, benzene, crown glass, this is a special type of glass. So for all of them you can see the refractive index. Similarly, there are different materials here, that Canada balsam, rock salt, you know, all these substances. Diamond, refractive index of diamond is very high, 2.42. So you don't need to remember all this. At the most, what you should remember is that refractive index of air is 1. Then refractive index of water is 1.33, and refractive index of glass is 1.5. Refractive index of glass is 1.5. So this is crown glass. Refractive index of crown glass is 1.52, but you can take it as 1.5. So this is all you need to remember, not other things. Okay, students, can you note one more thing here, that all these refractive indexes are greater than 1. Refractive index of a medium, index of a medium is always greater than equals to 1. You can see. See, this is greater than 1, greater than 1, greater than 1. All these are greater than 1. So this is an important point, students, that refractive index of a substance will always be greater than 1. Why will it always be greater than 1? Can you tell me? See, refractive index for a substance is defined as speed of light in vacuum divided by speed of light in medium. So as we have already discussed, speed of light in vacuum is maximum. So this quantity will be larger, and this quantity will be smaller. Will always be smaller. So the division of these two quantities will always be greater than equals to 1. That's why refractive index of any substance is greater than or equals to 1. Then students, we can also see one important term here, that is called optically denser medium. Optically denser medium and optically rarer medium. Optically rare medium. Now you will very often find these terms in this chapter. What is the meaning of this? Now suppose students, we take any two substances, say we take alcohol and kerosene. Alcohol and kerosene. Okay, alcohol and kerosene. Now look at their refractive indexes. Now if we compare these two, refractive index of kerosene 1.44 and for alcohol it is 1.36. Clearly the refractive index of kerosene is greater than refractive index of alcohol. Right students? So if we compare these two, we'll say that kerosene is a denser medium, optically denser medium, and alcohol is a optically rarer medium. You understand the point? Rarer medium. So if we compare two transparent mediums, the one having higher refractive index will be said to be denser, and the one having lower refractive index will be said to be rarer. Understand students? Now if you compare these two, rock salt and carbon disulfide, if you compare these two, which one is denser, which one is rarer? Clearly this has more refractive index, so this will be denser, this will be denser, and this has lesser refractive index, so this will be rarer. You understand my point students? So let us do this simple question students. So what is the question? That refractive index of carbon disulfide, some substance, refractive index of this substance is given as 1.63. Find a speed of light in this substance. Find a speed of light in this substance if C is given as this. Now what is the C students? C means speed of light. C means speed of light in vacuum. Okay students? C means speed of light in vacuum, and that is obviously 3 into 10 to the power 8 meter per second. Right? So C is a symbol which is used for speed of light in vacuum. Okay, anyways, so refractive index of carbon disulfide is given. So refractive index of carbon disulfide will be speed of light in vacuum divided by speed of light in carbon disulfide, right students? So refractive index is 1.63. Speed of light in vacuum is 3 into 10 to the power 8 meter per second, and then divided by speed of light in carbon disulfide. So clearly students, from here you can calculate speed of light in carbon disulfide as 3 into 10 to the power 8 meter per second divided by 1.63. If you calculate it, you will get our answer. So you can see it's a very simple question students. Now let's do one more question like this. So students, here the question is that you are given kerosene, turpentine and water. Okay, so we have to talk about these three transparent substances. In which of these does light travel fastest? Okay, so you are given three transparent mediums. We have to tell in which of these three light travels fastest. Use the table below. So we have to use this table. Okay students, so see, kerosene, refractive index of kerosene is 1.44. Turpentine, refractive index of turpentine is 1.47, and then water, refractive index of water is 1.33. Okay, so we know the refractive index of these three quantities. We have to comment about the speed of light in them. So students, see, refractive index is defined as speed of light in vacuum. When you write an exam, you have to write fully speed of light in vacuum, not in short. Okay, if you write in short, your teacher can cut your marks. So you have to write speed of light in vacuum. I am writing in short just to save time. Okay, so refractive index of substance is speed of light in vacuum divided by speed of light in that medium, isn't it? Okay, so see, if speed of light if speed of light is more, if speed of light in a medium is more, if speed of light in a medium is more, then refractive index will be less, isn't it? If speed of light in medium is more, refractive index will be less. Okay, so see, out of these three, refractive index is least for water. So refractive index is least for water. Refractive index is least for water. It means the speed will be maximum for water, right? So as this is refractive index is least for water, speed of light will be max for it, right? So what is our answer? That light travels fastest in water among these three substances.